Thank you for tuning into today's webinar, which is brought to you by H3 Platform, a composable infrastructure pioneer headquartered in Taiwan that has produced the world's first PCIe Gen4 composable GPU solution. We develop and sell the innovative PCIe fabric switch box as a composable solution that provides a true pool of PCIe disaggregated resources in a rack. And my name is Jessie Ye. I work in the sales and marketing department. Today, I will be taking you through how our solution can help the rendering artists, content creators work faster, smarter, and better by talking about the challenges facing them, low GPU utilization issue, what our solution offers to help, our solution architecture, product portfolio, and we will be running demos too. We will also go through the software features, key benefits, then we will conduct a Q&A session. The webinar will last for about 20 minutes, and we are hoping to see you sit through the entire presentation. So what are the key system challenges that rendering process has? It's time-consuming. It leaves the GPUs at idle when not in use, and it's difficult to upgrade the system. Oftentimes, designer and rendering artists have to either patiently wait for the rendering to be done, especially when doing the batch rendering, or leave the GPU resources at idle or underutilized when creating the content. When GPU utilization is often low and GPU resources can be shared across different users or machines, users often tend to purchase the more affordable mid-range GPUs in order to save money. But the reality is, the mid-range GPU takes longer time to render, and it's hard to produce the photorealistic images when compared to the high-end GPU. So if you can use the high-end GPUs and share these GPUs with other people across different machines when not in use, everybody's productivity will be greatly improved, as the creative workflows will also move much more smoothly. And in the end, the total cost of using a composable GPU solution then will be much lower than using expensive GPU servers. And besides, the integrated GPU server is difficult to upgrade, such as swapping out the GPU, swapping out the CPU, adding memory, and so on. And how can these challenges be addressed then? Our disaggregated chassis provides a fluid, flexible resource pool, and GPUs installed inside the chassis can be shared across different users or servers configured through our web-based management user interface. The system topology of our composable GPU solution is shown as the diagram. Two 16-slot GPU chassis represents the GPU resource pool, and in this rendering cluster, 4 rendering servers are connected to two 16-slot GPU chassis through CDFP cable. And the GPUs inside the GPU resource pool can be dynamically provisioned to any connected host servers online. For example, when the first server needs 8 GPUs in the GPU resource pool can be assigned to the first server. And when the first server later on only needs 4 GPUs, 4 GPUs out of 8 then can be released back to the GPU pool for other connected servers. And through this dynamic provision, GPUs can be repeatedly shared across different designer and rendering artists to meet the changing workloads at any time. And during the GPU resource allocation and reallocation, all the servers and GPU chassis can stay online, as there's no need to reboot any systems. We can add or remove the GPUs on the fly. Now, we will be running Maya to demonstrate composability and analytics features our solution has. Composability is the dynamic provisioning capability, while the analytics show the GPU core utilization and PCIe throughput performance. Let's get started. Let's first have a quick look at the demo topology shown as the diagram. And in this GPU cluster, one AMD PCIe Gen4 server and one Intel Gen3 server are connected to a 16-slot GPU chassis through CDFP cables. Two NVIDIA P100s and through P400s are in this GPU chassis. Maya is installed on the AMD server, and one P100 GPU is assigned to the AMD server, while two P400 GPUs are assigned to the Intel server. During the demo, Maya on the AMD server will use one P100 or two P100 GPUs to render, while the Intel server is running the stress test with two P400s. We run Maya and GPU stress tests at the same time to simulate two or more servers can be using the GPUs concurrently in the real application scenario. I'm going to show you how GPUs get assigned to the connected servers. There is no any GPU now in the Intel server. Let's use the management user interface to assign two P400s to the Intel server. The first assignment, select the GPU, select the Intel server, then click Allocate. Then the second assignment. Now two P400s, which are highlighted in green, are being provisioned to the Intel server. Let's use the NVIDIA SMI to check if these two GPUs are being assigned or not, as these two GPUs are also being hot plugged into the Intel server. Now let's run the bandwidth stress test on the Intel server. Let's check on the PCIe throughput right now. The performance is around 14 GB per second from host to device. Now we are going to assign one P100 GPU to the AMD server. Again, select the GPU, select the AMD server, then click Allocate. Now one P100, which is marked in purple, is being provisioned to the AMD server. And again, one P100 is being hot plugged into the AMD server. Now let's open Maya and load a 3D image. So while we're waiting for this process to come through, let me go through what we have done and what we are doing here again. One P100 GPU in the GPU resource pool, which is referred to as Falcon 4016, has been assigned to the AMD server, which is connected to a Falcon 4016 by using CDFP cable. And Maya installed on the AMD server then can see the assigned GPU and is using this P100 for rendering. So as this is a light demo, so every little step takes some time, so please bear with us and thank you for your patience. And now the 3D image is loading, which is going to take a while. Now let's start to render. So for the demo purpose, we will render the image to a relatively low resolution image. Let's go check out the PCIe traffic Maya has. It's around 170 megabytes per second on the AMD server right now. And the performance on the Intel server is 14 gigabytes per second. And while we are waiting for the rendering to be completed, let me also explain a little bit about our purpose and procedures behind the demo. They are to show how to dynamically allocate the GPUs on demand and online to the multiple connected servers by our management user interface without shutting down any machines. So there are two scenarios. We first run Maya by using one GPU, then run Maya by using two GPUs, and we compare the time saved between these two use cases. So when using one GPU to render, it takes around 1 minute and 25 seconds. Now let's shut down Maya. Shutting down is going to take some time too. And let's assign one more P100 GPU to the AMD server. And again, one more P100 GPU is being hot plugged into the AMD server. So we now have two P100s. Let's open Maya and load the 3D image again. And while we're waiting for the process to come through, let me show you how you can go around our product page for the additional information you might be interested in. Here you can see the software features including GPU dynamic provisioning, device hot plug, and performance monitoring. There's also spec, including 16 GPU slots and 4 host slots. There is compatibility list, including devices such as NVIDIA Tesla and AMD Radeon GPUs, as well as OS, such as CentOS, Ubuntu, and Windows. You can also see the product photos, including the Falcon 4016 system and GPU drawer. And if you want to see our Falcon 4016 in action, you can leave a message by clicking Request a Demo. Now Maya can also see two P100 GPU. Let's start the rendering. So again, for the demo purpose, we will render the image to a relatively low resolution image. Let's go check the PCIe throughput on the management user interface. The traffic is around 330 megabytes per second on the AMD server. Meanwhile, the performance on the Intel server is still 14 gigabytes per second. We're waiting for the Maya rendering to be done. When using two GPUs to render, it takes around 46 seconds. It means that while Intel server is using two P400s and AMD server is using two P100s at the same time, all the GPUs can still be used to their full performance for each server. So since the rendering workload is primarily GPU bound, by adding one more GPU, rendering time can be improved by 50% with 100% PCIe throughput and 100% GPU utilization. Please note that different GPU models, different video editing software will get different performance results, as we don't get to control how GPU or video editing application performs. Here we basically want to tell you that how you can use our solution to dynamically allocate and reallocate the GPU resources to your different connected servers to manage your creative workflows precisely and efficiently. And as our chassis can accommodate up to 16 GPUs per unit, you can assign as many GPUs as you want to achieve the maximum efficiency when needed. So why does composable GPU solution matter then? In short, it helps lower the infrastructure cost, provide the flexibility to configure and reconfigure the service on demand, drive up the resource utilization, and increase the artist's productivity. And since GPUs can be shared with flexibility across different users or servers, you can purchase less but better GPUs to further reduce the rendering time and increase the productivity. Besides, since the GPU chassis is connected to the servers by CDFP cable, it's also easier to expand the GPUs for existing GPU rendering servers. So in terms of our product portfolio, we have two different PCIe Gen4 composable models, 16-slot GPU chassis and 8-slot GPU chassis. 16 GPU model supports up to 4 hosts, and 8 GPU model supports up to 8 hosts. All GPU slots are PCIe Gen4 by 16 and can be backward compatible with the PCIe Gen4 devices. So as a wrap up, today we have talked about the system challenges that rendering has, idle GPUs, our solution, etc. We have also shown you how to assign the GPUs across different servers on the fly. Please be reminded again that allocating the GPUs to the connected servers can be done online without shutting down any server. So if you are interested in finding out more about us after this webinar, you can visit us at www.h3platform.com for more details. You can also reach out to us by online chat or schedule a product demo with us if there is any specific feature or configuration that you would like to dig deeper into. So now any questions? If you have any questions, you can use the chat window to type your questions down and we will answer. Okay, there's a question coming from Alex, which is about the GA schedule, general availability schedule for 4016 and 4008. So the answer is we will start shipping 4016 this month, while for 4008 for now, we are looking at April to start shipping the samples and June for the fully certified products. Okay, there's another question coming from Mr. Takaoka, who wants to know more about our price list. Okay, so Takaoka-san, I will get back to you by email about our Intel price list later, because it's a little bit complicated to go through the entire thing. So we will touch on that more later on. Okay, thank you. So let's see if there's any more questions. Okay. All right, there's another question coming from Alan, who wants to know more about our API management feature. So yes, we provide API management feature, and it's Redfish RESTful API, and it's gonna be available after April. So okay, one more question. Do you need to install any software on the host? Okay, there is no need to install any software on the host server, as we simply use the device native drivers on the host OS. Okay, I think these are all the questions that we have for today. So if there is no more question, please feel free to drop us an email if you need any further information later on. So thank you again for being with us today. We will see you next time. So have a good day and have a good night. Bye-bye.